So far, we've only been focusing on the programmer perspective for using factor methods in the Java Completable Futures framework. What we're going to do now is we're going to take a peek under the hood and see how these factor methods are implemented internally. And so we're going to do this primarily for the factor method implementations. The other implementations are much more complicated than I want to go into, but we'll at least look into factor methods and see how they work behind the scenes. So here's the example. This is just the example we saw before in my EX8 project, in my Java 8 folder, in my live lessons repository, where we're going to call supplyAsync and give it a supplier lambda to do the thing in the background. Now, a couple things to note. Calling supplyAsync does not create a new thread, or at least it's unlikely to create a new thread. Instead, what it does is it schedules this computation to run in the background and returns a completable future that will be processed by a worker thread that will run this supplier lambda in the background. SupplyAsync's parameter is a supplier lambda, as you can see here, that multiplies two big fractions. I should also kind of just point out maybe the obvious. Notice how these more advanced modern Java features, like parallel streams, like completable futures, leverage the more foundational functional programming features you get with modern Java, such as lambda expressions, method references, functional interfaces, and so on and so forth. So they're really taking those basic building blocks and then doing all kinds of cool things with them. In this case, queuing up a lambda expression instance and then being able to run it in a different context, namely off the main thread of control. Here we go. You can see this. This is the same thing we've talked about before. We can use effectively final parameters to pass parameters to supplier lambdas, which otherwise don't appear to take parameters, but we can do it this way, which is perfectly fine. And then the worker thread running in the common fork join pool, when that is ready to run, will just call the get method on this supplier lambda. So remember, supplier lambda has a get method that's the abstract method associated with that supplier. And it will call that get method in order to perform this computation. So we're bundling up this computation into a lambda and then queuing it up and passing it around throughout the infrastructure in the Java Completable Futures framework and the common fork join pool. So let's go ahead and take a look now at how the implementation works behind the scenes. This is actually pretty cool. So here's the supplyAsync method. You can go find this in the Java source code. Java 8 and beyond will have this. And you can see it's passed a supplier. And internally, it's going to go ahead and use that supplier together with some other internal classes that you don't see as an application developer in order to be able to perform the computation in the context of the common fork join pool. So you can see here, this is the supplier that's passed in, which in our case was that supplier lambda that multiplied the two big fractions together. You can see how a new instance of a class called async supply is created, passing in the supplier as the parameter. And we also, notice this is kind of interesting, we also pass in a completable future that has not yet been completed. So we're passing in a completable future and a supplier to this async supply method. And then we enqueue this execute or exec async method. We'll go ahead and enqueue this object that encapsulates the supplier and the incomplete completable future in the common fork join pool. This is a great example of the message passing principle described in the reactive programming model. So if you look at the reactive programming manifesto, you will see that they talk about the concept of message passing as one of the principles. This is a message passing model. So we're converting a nice high-level API call that's a method-oriented API call called supplyAsync, and we're turning it into something that can be passed around as a message. Here's the async supply class. Again, you can find that in the source code. It extends something called async. We'll talk about that in a second. The async class is an internal class to the Java Completable Futures framework that extends the fork join task and runnable classes or interfaces. And that allows it to be executed in a thread pool. So async supply extends async, and you'll see what that means in a second. Here's the constructor of async supply. You can see what it does is it takes the supplier lambda, and it also takes that other thing that's passed in, which was the completable future, and it stashes that away in a local field called fn, which probably stands for function. And so that's storing that supplier lambda. That's that anonymous block of code that does this multiply operation. The exec call, the exec method, is dispatched by a worker thread in the pool. And that's a hook, which is implemented from the async superclass, that, as you can see, calls the get method on the function supplier. I don't know why they didn't call that sup or su instead of fun or function. But whatever the case may be, we're calling the get method on this supplier. That's going to compute the result. And keep in mind, this is running in a background thread in the common fork join pool. So that operation is being invoked in a different context from where it was created. Now, if we're really clever, and we didn't need to do this for our simple use case of multiplying operations, because that is a CPU-bound job, if we needed to do something more sophisticated that involved blocking, like some kind of I/O computation, then we could wrap this up with the fork join pool managed blocker mechanism in order to do that, in order to auto-scale the pool size for blocking operations. So that's the end of the overview of the supplyAsync method for Java completable futures. I think you'll appreciate the fact that you don't have to know all these low-level gory details of message passing, and instead the completable future facade encapsulates you from those types of details.